Hello dear aspirants. In some of the previous class videos, I have discussed the divisibility test for certain single digit number. In this video, I am going to discuss the divisibility test for certain two digit number. Okay. So let us take this example. So for this given number, so this is the given number. I want to know whether this number is divisible by 12 or not. So 12 is a two-digit number. So for 12, what is that we have to do? We have to write this 12 as a product of two co-primes or relatively primes. That means what? I can write 12 as 3 into 4. Two numbers are said to be relatively prime or co-prime when their HCF is going to be 1. That means highest common factor for both the numbers will be what? 1. So now 12 I am writing as 3 into 4. So this number, if it is divisible by both 4 as well as 3, then this number is said to be what? Divisible by 12. So whether this number is divisible by 4 or not, how do you check it? You go to the last two digit of the number. If the last two digit is divisible by 4, then the entire number is divisible by 4. The last two digit 24, it is divisible by 4. Whether this number is divisible by 3 or not, what is that you have to do? You have to add all the digits. Sum of the digits should be what? Multiple of 3. So it's going to be 6, 10, 17, 23, 28, 30. 30 is divisible by 3. Therefore, this is also divisible by 1. This entire number is divisible by 3. Therefore, since this number is divisible by both 3 as well as 4, therefore this number is what? Divisible by 12. Next, let us take this number. We are going to check whether this number is divisible by 14 or not. What is that? After 14 is a two-digit number. You try to write as a product of two co-primes. That means 14 can be written as 2 into 7. So whether this number, now what? In order to check whether this number is divisible by 14 or not, I need to check whether this number is divisible by 2 and 7. So whether it is divisible by 2, yes, the last digit is what? Unit digit is 8, therefore it is divisible by 2. Whether this number is divisible by 7 or not. 7 divisibility test is from the right you separate the numbers into three numbers and find the difference. It is 938 minus 715. So it's going to be what? It is 223. 223. That's what we'll be getting. So now this 223, whether it is divisible by 7 or not. How to check it? Either you can divide by 7 and if there is a remainder, then it is not divisible. The remainder becomes 0, then it is divisible by 7. Or else there is another shortcut also for a simple number like this. You take the last digit, keep the remaining number as it is, multiply the last digit by 2, it is going to become 6. 22 minus 6, it's going to be what? 16. 16 is not divisible by 7. Therefore, this number, the entire number is not divisible by 7. So, we are finding the difference between these two numbers, three numbers. And then what? Whatever the resultant number you are having, this number if it is divisible by 7, this number is divisible by 7. If not, this number is not divisible by 7, then this number is not divisible by 7. Okay. So this is not divisible by 7. Of course, it is divisible by 2. Therefore, what? It is not divisible by 70. It is not divisible by 7. If it is divisible by 7 as well as 2, then it will become what? Divisible by 14. Okay. Next, let us take another number, 21. Whether we'll check whether this number is divisible by 21 number. So 21 is a two-digit number. What is that I have to do? I have to write this as what? Product of two co-primes. 21 is going to be 3 into 7. Highest common factor for 3 and 7 is what? 1. Therefore, these two are what? Co-primes. So in order to check whether this number is divisible by 21, I need to check what? Whether this number is divisible by 7 as well as divisible by 3. Is it divisible by 3? Yes. So if you, this is what? 3, 6, 9, and then it's going to be 12. So it's going to be what? Divisible by 3. Whether it is divisible by 7, Again, you have to do the same process. It's going to be what? You take 3, 2, 1, you separate them into three numbers. You take all the numbers available in the odd places, add them if you have more numbers. All the numbers available in the even places, add them. Some of the numbers dot places, some of the numbers in the even places you have already taken after separating three numbers. The difference is divisible by 7 or 0. Then the number is going to be divisible by 7. Hope you are understanding. Now I'm separating three numbers. I get what? 3 to 1. Next is what? 1, 2, 3. If I take the difference, it's going to be 198. Whether 198 is divisible by 7, you can do the ordinary division or else what? As I said, you take 19, take the last digit, unit digit, multiply by 2, it is 18. Subtracted, it's going to be what? 1. So we are getting 1. 1 is not divisible by 7. Therefore, this number is not divisible by 7. If this number is not divisible by 7, this number is not divisible by 7. If this is not divisible by 7, definitely it is not going to be divisible by 21. So the logic is when you are having two digits, you try to write as a product of two co-primes. Okay. Then the two co-prime number and you have to check the divisibility test. For both the number satisfies means then the entire number is divisible by the two-digit number. Otherwise, it is not. Okay, this is the logic. Okay. Now using this logic, let us solve some of the SSC PYQ. Look at this question. Which of the following number is not divisible by 15? Not divisible by 15. If you want to say certain number is divisible by 15, what is that you have to do? 15 can be written as 3 into 5 and 3 and 5 are what? Co-primes, relatively prime, which means the HCM is going to be 1. Now, all the numbers ending with 5, all the numbers are what? Divisible by 5. Now I have to check with the 3. A number which is divisible by 3, then it is going to be what? Divisible by 15 now. And the question is a number which is not divisible. Okay. So now let's find whether this number is divisible by 3 or not. It's going to be 10, 19, 21. 21 is divisible by 3. And then 10, I have one here, 18. 18 is divisible by 3. And then this number will take here 10. Again, 18. 18 is divisible by 3. And then here it's going to be what? 18, 20, 25. 25 is not divisible by 3. Though this number is divisible by 5, but it is not divisible by 3. Therefore, this number is not divisible by 15. The question is not divisible. So, the question is the answer. This is how we have to answer. Now, let's take another example. Another PYQ. Which of the following number is not divisible by 36? Again, similar, not divisible by 36. 36, how you write as product of two co-primes? It's going to be what? 4 and 9. For 4 and 9, HCM is going to be 1. Therefore, they are not relatively prime or co-prime. Now, we have to check which number. If it is divisible by both the number, then it is divisible by what? 36. If it is not divisible by any one of the number or both the number, then it is not going to be divisible by 36. Let's verify. So for 4, what is the divisibility test? Last two digits need to be what? Divisible by 4. So here 16, 84, 44, 16, all are what? Last two digits are divisible by what? 4. So now we have to check only 9. Now for 9, we can cancel with what? You can either you add or you can cancel. So going with the cancellation 9. So then it is going to be 9. Then 1 we have. This number is not divisible by 9. Okay. If this is not divisible by 9, then it is not going to be divisible by 36. Let's verify the other number. Answer comes, seems to be this number. Let's verify the other number. So 9, 9 we cancel. Like 7, 9 cancel. And then 8, 1, 9 cancel. So it is divisible by 9. Also divisible by 4. Therefore, it is divisible by 36. The question is not divisible by 36. Now let's go with this number 9. and then 819. So it is also divisible by 9 as well as 4. This is divisible by 36. So now here 9 you cancel, and then 7, then 2 is there, then 16 plus 2, 18, all are what? I mean, this number is also, you are able to pair like 9, 9. Therefore, it is divisible by what? 9. So it is divisible by 4 as well as divisible by 9. Therefore, it is divisible by 36. The question is not divisible. So this is divisible by 4, but it is not divisible by 9. Therefore, this is the answer for the question. Okay. So this is how we have to check whether the given number is divisible by a two-digit number. Okay. So having understood this concept, similarly, you can try and answer this question. Okay. Thank you.